up or going down. So this is limber pine, again, in the Great Basin ranges. During the same period that it's recruiting above its tree line, current tree line, it's also going down. It's going down only in specific areas, and those are cold ravines on north slopes that are sheltered. They're narrow. These are not glaciated mountains, so they have very narrow canyons, so there's not much solar radiation there. And here they are at the same period of time as they were going upslope. And again, a very limited time period where they're not as much recruitment at present. And we're chasing this idea at present. It's one of our current studies in progress, which is the possibility that these low north slope, low ravines, where species are below their primary species range, may actually have been refugial in the past during warm conditions and may actually be refugia for these species in these mountain ranges in the future. So gathering data that we have a lot of distributional data from our colleague David Charlight of different conifer species in these Great Basin ranges. And if we look at all of the records that we have and divide them into their elevational quartiles for each of the species and look only at the low elevation quartile and ask what percentage are in those canyon and ravine locations, they're really pretty high. From 100% for Doug fir to 90% for Engelmann spruce, and an average of about 63% are in those positions. So we're thinking they may be very important in recolonization of some of the upper slopes. And again, think cold air drainage, think low solar radiation, think higher water tables. So these may be reasons why these species are there. And now in the last few slides, I'm going to close with bringing us around back to pika. Again, thanks to Kaylin for doing all the hard work of introducing the species biology. But it's an example of a species that exemplifies microclimates, the importance of microclimates, and how conditions can be quite different from species that sense more broad-spread climates. So as Kaylin has suggested, American pika, this is a relative of rabbits. It's not a rodent. It's a mountain species. It's commonly thought of as an alpine species, which is incorrect. It has a much broader zone than just being in the alpine or even the upper montane region. It is talus dependent. Talus is a broken rock landform. It lives in the talus and it feeds in the vegetation in front. As Kaylin said, it's non-hibernating, so it must collect vegetation for the winter. And all rabbits, but in particular pikas, are temperature sensitive. They have high body temperatures and they have very low lethal temperatures. So they don't have much wiggle room when temperatures are warming. They have been petitioned at both federal level and state level for listing under Endangered Species Act. So there's been a concern. There's sort of been the icon of sensitivity. They are like the temperate polar bear, if you will. And here's typical habitat. Lundy Canyon, Upper Lundy Canyon. This is just great pika country. This talus, then they feed along the borders here. This is going up to Moat Lake in Virginia Canyon. Here's one of their hay piles. They were humongous last year. They're just incredible, these stalks, and they're every 50 feet or so. Here's Gardiski Dale. I think I saw her when Greg and Autumn were hiking up last Chautauqua to Gardiski Lake. So there's typical habitat. But they do, as I say, they do come down into low elevations. And I've been spending the last 8 years with Bob and other colleagues studying the thermal regimes of the taluses that they live in. And not just the high elevation taluses, but taluses at low elevations. And you do find them down into areas that are below they're into the pinyon woodland zone, they're into the sage steppe zone. They have areas where there's very little vegetation in the forefields. And what I'm showing you here are, over the course of summer, the blue line are the temperatures from eye buttons, like Kaylin used, in the talus matrix, and the red is the surface temperatures. The blue line is considered a very dangerous temperature for pikas. So you can see in the interior, look at this, and how cold it is in the talus. And this is from Obsidian Dome. There are also, this is habitat near the pumice mine in South Mono Craters. You can see this is not your typical alpine environment. This is lower Levine Canyon. So in effect, this, and what we have found by studying talus alone, is that the processes inside the talus are very different from what's happening in free air. Think of like an ice cave. So they set up very different circulation patterns. that keep them really independent of what's going on outside. And basically what's going on inside is that they're cool and buffered in summer, and in winter they're warmer than the external air, and they're warmer even than the surface of the matrix. So it's really a very protective environment. And that because, as Kaylin was suggesting also, pikas are behaviorally able to adapt. They can be like if you're in Phoenix during a heat wave. They stay in the talus when it's particularly hot. They're able to come out when it's cool. And I would suggest that they do have more opportunities to forage, because they actually do forage at night. They can do that. And as the summers are longer, by less snowpack, they have a longer time to collect forage. So in fact, it's during the very high snowpacked years, when there's a short summer, that it's very challenging for them because they don't have enough time to collect vegetation. So these talus environments that have microclimate processes ongoing provide a really good habitat for this small animal that's not a very good thermoregulator. The other thing that these talus and rock glacier features, they tend to have long-lasting ice within them. They set up, there can be permafrost at much lower than expected levels. And because of that, they have long persisting springs that keep flowing even during drought years when other springs at this elevations dry up. So they set up these, they're very important hydrologically where they occur, and because there are persistent springs, they're keeping the vegetation in the forefield green much longer than areas where there is not talus. So another study we have done has shown that the species diversity in these talus-fed meadows is much higher than in non-talus meadows. And a lot of animals besides pikas live there. So these are very good sort of interconnected ecosystem that supports the condition even down in much lower elevations, such as where I was showing you with the domes, the volcanic domes, can provide conditions for these pikas to persist. So I'm sort of on a track. Here's another one of Ken Hickman's. He's the camera guru that Kaylin also mentioned and did the pictures up close in the hay piles. My path now is to explore the idea that instead of an icon of climate vulnerability, we might consider pikas as a model of resilience and adaptive capacity, interacting with these unusual microclimate processes of their habitat. So just wrapping up then, we can take all of this information, if we're concerned about climate action and vulnerability, and recognize that moving up slope isn't the only potential, that going off the tops of mountains isn't the only fate, that there are, especially in the sort of 100-year time scale, other ways for species to respond. And you have to really take into account the species of interest, the location of interests. And we do have a lot of options, a lot of different kinds of strategies. This can be another whole talk, but going from a more conservative and short-term, promoting resistance to climate change, trying to improve resilience to climate change, or enabling species to have their own resilience capacities, and those species that are moving to assist in their transitions. And finally, if they're disrupted ecosystems, there are actions we can take to help realign or restore those. And that I think you'll hear from Sarah Stock when she talks about the bighorn sheep. So if you are interested, as I mentioned, there are publications that support these different frameworks that I've been talking about, and I welcome you to look at those and also ask any questions that you might have when we have a chance. Thank you so much for your attention. I could if you're not too hot and been a long sit through that.
Maybe a couple questions and we'll take a break because we have to change computers for a break.
Or we can take them after also. It's a lot at once, yeah.
Almost everything you referred to didn't really look at rates of change. In the past, what you were referring to occurred over thousands of years. What's occurring now is occurring over decades. What's your take on that question?
So my take is that that's true at the global level, that rates of change, well, I'll even back off that. It depends on where you want to focus, but there are many situations where rates of change have been as fast or faster if you look at coming out of the last ice age. And there are periods where, that's why I wanted to stress that our species, that's something they have gone through several times. So it's not the dominant pace of change, but it's not unique to our species. So coming out of these reversals, there were situations where 10 degrees Celsius was occurring over 30 years. Those were periodic times throughout. So going in and out of the medieval climate anomaly, that was within decades. So it's not entirely, that's a very common question, I understand entirely, and I think it's when we bring these to local regions, we really have to look at conditions that happened here. So I think there is precedence for rates of change there. There's certainly not precedent for rates of change when there's the pervasive land use effects that humans have imposed. So putting the pervasive, everything else that is going to constrain capacity of species to move. Land use, invasive species, changes in human patterns on the landscape make it very difficult for species to move the way they might be able to adaptively, even if conditions were at the same rate.
Want to talk a little bit about field trip?
Yeah, we can do that.